In June 1942, one severed oil line over Alaska handed the United States the technical blueprints required to dismantle the Japanese air fleet. The Aleutian Islands campaign was a brutal theater of fog and steel. Tadayoshi Koga steered his A6M toward Dutch Harbor. Anti-aircraft fire from the ground clipped his machine. Oil sprayed. The pressure dropped. Koga banked toward Akutan Island, a designated emergency extraction point. He lowered the tailhook. He flared for a landing. The Zero weighed 2,400 kilograms. The ground at Akutan was not solid earth. It was a soft, deceptive bog. Koga touched down. The landing gear tires hit the muck. The struts groaned under the sudden hydraulic resistance. Then, the metal snapped. The sound of shearing aluminum echoed across the tundra. The aircraft's nose dug into the mud, and the entire fuselage flipped onto its back. The impact was vertical and absolute. Tadayoshi Koga died instantly. The fighter remained there, inverted and silver against the green moss. For 5 weeks, the Pacific's greatest secret sat in the mud. Then, an American PBY Catalina patrol plane banked over the island. The pilot spotted the wreck. U.S. Navy recovery teams arrived with heavy cables. They hauled the fighter from the marsh. Every bolt and every rivet of the Imperial Navy's pride was now a trophy. Within weeks, this same fuselage would sit in a San Diego hangar, surrendering every Japanese secret to Allied wrenches. The Navy shipped the restored fighter to North Island Naval Air Station in San Diego. In San Diego, engineers stripped the captured Zero to its skeleton. When test pilots pushed the restored machine into a high-speed dive, the airframe began to resist. How do you kill an aircraft that outturns everything in the sky? You force it into a dive where its controls lock. The Zero lacked hydraulic assistance. At 400 kilometers per hour, the pilot had to put over 20 kilograms of physical pressure on the stick just to roll. The aerodynamics were asymmetrical. It rolled easily to the left, but resisted to the right. In a dogfight, the Japanese pilot was a prisoner of his own physics. His movements became predictable. Contrast defined the machine. At low speeds, it was a ghost. At high speeds, it was a brick. The technical flaws went deeper than the skin. The A6M used a float-type carburetor. During zero-gravity maneuvers or inverted flight, the engine flooded and stalled. While the British had fixed this exact flaw in the Spitfire, the Japanese never did. The airframe was a flying tinderbox. No armor plate protected the pilot. No rubber coating sealed the fuel tanks. A single burst of 50 caliber rounds from a Grumman Wildcat would ignite the extra super duralumin wing. Intelligence officers translated these mechanical failures into tactical manuals. Pilots received new orders: never turn, never stall, and always boom and zoom. The data moved from the cockpit to the drafting board. Engineers at Grumman received the final telemetry and adjusted the specifications of their new project, the F6F Hellcat. Structural fragility found by Grumman engineers was no mistake. It was a rigid requirement of the Imperial Navy. To achieve the impossible, Mitsubishi had to discard the rule book. 1.2 millimeters. That was the maximum thickness of the Zero skin at its strongest points. In the rear, it dropped to just 0.5. Why remove self-sealing tanks and pilot armor? To meet an uncompromising demand for a 1,900-mile range. Nakajima, a major competitor, reviewed the Navy's specifications. They called them impossible and abandoned the project. Jiro Horikoshi did not. He turned to extra super duralumin. This aluminum alloy, treated with German techniques, made the frame 40% lighter than standard steel. The pilot presses a button on the fuselage. 2 hidden footholds and a handle pop out from the frame. He climbs up, careful not to step on the wings. One wrong move would dent the airframe like a soda can. He slides into the cockpit, then the steps retract. The surface remains perfectly smooth. Flush riveting sealed the exterior. Metal clicked into place, leaving no drag. To shave more grams, Horikoshi ordered holes drilled directly into the structural ribs. Every gram saved was an extra meter of distance. The wings spanned 12 meters. They were built for the cramped elevators of Japanese carriers. Inside the fuselage, engineers tucked inflatable flotation bags. If a pilot ditched at sea, air from the engine intake filled the bladders to keep the craft buoyant. The Japanese called it the Raizen. It was named for the imperial year 2600. In the West, it was simply the Zero. It entered service in 1940. Western observers dismissed the reports until 1941. Then the math became undeniable. The fuselage skin near the tail measured exactly 0.5 millimeters, 12:1. That was the kill ratio in the skies over China in 1940. American intelligence received the reports. They didn't believe them. A fighter with extreme speed, heavy cannons, and infinite range seemed impossible. Allied observers dismissed the data as a Japanese exaggeration. They were wrong. The strategic reality of the Pacific demanded a weapon that didn't exist. To justify the radical weight cutting and lack of armor, chief designer Jiro Horikoshi at the Mitsubishi plant had to fulfill a brutal naval directive. Japan needed to project power across an ocean, not a border. The result was the A6M Zero. By 1940, this machine outperformed the British Spitfire and the German Messerschmitt Bf-109. It was a long-range predator designed for a specific geopolitical goal, dominating two Western navies simultaneously from the decks of moving carriers. Its reach was its greatest weapon. A combat radius of 1,900 miles allowed the Imperial Navy to strike from Formosa to the Philippines without refueling. No Allied fighter could follow. Horikoshi achieved this through structural extremism. The airframe used a new light aluminum alloy. The entire aircraft weighed less than 2,000 kilograms. Large wings and a slim fuselage turned a modest engine into a master of maneuverability. The Zero carried two 7.7mm machine guns and two 20mm cannons. The Zero was a weapon of extremes. It stripped away steel for speed. To control this machine, the Imperial Japanese Navy required more than just pilots. They needed biological components, precision engineered through attrition. Who could survive in a cockpit without armor plating? Only the top tier of naval aviation cadets. In July 1940, the selection process resembled a meat grinder. The Navy prioritized absolute quality over mass production. The training was a brutal filter. Instructors pushed candidates to the edge of physical collapse. Cadets endured sleep deprivation and relentless discipline. Each year, only about 100 graduates earned their wings. This tiny elite became the central nervous system of the Zero. The airframe had no self-sealing fuel tanks, no backrest protection. The pilot's only shield was his own situational awareness. The system relied entirely on this unreplaceable human resource. There was no margin for error. In the skies over China, the massacre began. Soviet-built Polikarpov biplanes burned in midair. They were obsolete, poorly maintained, flown by under-trained pilots. The Zero cut through them like a scalpel through paper. Western observers dismissed the reports. They didn't believe a Japanese fighter could achieve such lethality. This skepticism died on December 7, 1941. The Imperial Navy combined its elite pilot corps with a machine boasting a 1,900-mile range. This system struck Pearl Harbor. The goal was surgical: cripple the United States Pacific Fleet, neutralize American interference in Asia. The Zero flew escort for the bombers. It patrolled the airfields while battleships sank. Only a few American pilots reached their cockpits. George Welch and Kenneth Taylor scrambled their P-40 Warhawks into a swarm of Japanese steel. They fought. They even scored kills. But the math was impossible. The Warhawk was faster on paper. In reality, it was a brick. It could not match the maneuverability of the Zero or the reflex of the Japanese pilot. By the end of the day, the United States was at war. The Zero now controlled 30 million square miles of ocean. Japan projected power across Southeast Asia without resistance. In April 1942, the carriers entered the Indian Ocean. They struck British bases in Ceylon. Royal Air Force pilots rose to meet them. Hawker Hurricanes engaged in traditional dogfights. They attempted to outturn the Zero. It was a fatal mistake. The Japanese fighter circled tighter and struck faster. The Zero intercepted and shredded the hurricanes over Sri Lanka. While British and American squadrons faced slaughter in the skies over Asia, Lieutenant Commander John S. Thach sought a geometric solution. He sat at his kitchen table. He laid out matchsticks on the wood. He knew the F4F Wildcat weighed 1,000 kilograms more than the Zero. In a traditional dogfight, the American plane was a flying coffin. How could two slow, heavy machines survive? Create a cross-vector of fire. Thach devised a defensive formation of two pairs of fighters. When a Zero locked onto the tail of one Wildcat, both American pilots turned toward each other. The Japanese pilot, focused on his kill, would fly directly into the path of the wingman's machine guns. In June 1942, the matchstick theory met reality at the Battle of Midway. The tactic became known as the Thach Weave. It neutralized the Zero's mechanical superiority through pure mathematics. The Japanese carrier force was crippled, and the myth of the invincible fighter vanished over the Pacific. A single formation required a minimum of 4. Midway was a tactical fracture. By June 1944, that fracture became an industrial abyss. Thousands of F6F Hellcats flooded the Pacific, turning the sky into a wall of American aluminum. The scene over the Marianas was mechanical slaughter. American pilots sat behind 2,000 horsepower Pratt & Whitney engines. The roar drowned out the lighter Japanese Sakai motors. Tracers tore through the unarmored Zeros. In a single day, the Imperial Navy lost over 300 aircraft. U.S. sailors watched the horizon and called it the Great Marianas Turkey Shoot. How does a master craftsman fight a conveyor belt? He doesn't. He vanishes. The Hellcat was built to kill the Zero. It was faster, heavier, and virtually indestructible. Japan tried to respond with the A6M Zero. It was the successor the pilots begged for. It flew in May 1944, but the factories were dying. Japan built only 9 units of the Zero. While the U.S. perfected a few dominant platforms, Tokyo panicked. They diverted steel and fuel into 90 different aviation projects simultaneously. Resources evaporated. The Shiden and Raiden programs competed for the same dwindling parts. 12,000 Hellcats rolled off American lines during the war. Japan countered with 90 major aircraft designs. The training infrastructure of the Imperial Navy fractured beyond repair. It could not replace the elite airmen lost to American Hellcats and the Thach Weave. By 1944, the system reached a terminal state. A recruit climbs into a cockpit. He checks his gauges. This is an aging Zero, unarmored and unforgiving. He is 19 years old. He has 40 hours of flight time. High above him, the Americans wait. The contrast was lethal. A Japanese pilot entered combat with 40 hours of training. An American pilot arrived with 500. What happens when a novice sits in a plane with zero armor? He becomes a single-use guided bomb. The elite veterans of 1940 were gone. The new pilots lacked the skill to exploit the Zero's maneuverability. Without protection, their flight time dropped by 90%. The legendary fighter was now a coffin. Tactics shifted from dogfighting to suicide. Kamikazes burned through the remaining air strength for minimal gain. By August 1945, the collapse was total. Silver specks appeared over Hiroshima. These were B-29 bombers. They carried no fighter escort. They didn't need one. No resistance in the air.